This video will demonstrate how to implement the array index operator for the array type. Hello, I'm James Helfrich. The array index operator for the array type is implemented using pointer arithmetic. And to understand how this works, we're going to have to understand pointers a little bit. This video will demonstrate how all that works. An array is a collection of elements residing in a contiguous block of memory, and that contiguous block of memory is the key. So here I'll have an array of 10 characters. I'm going to treat these as 1-byte integers. These have the value 0 through 9. I'm also going to point to the first element, which has the value 0. When I break into the debugger, we're going to see that 0, 1, 2, 3, 4, all these values reside in a contiguous block of memory. Let's take a look at that memory, except we're going to lay it out horizontally. Notice that the first element is in FA48, and then 49 is the next element, and then A, B, C, these are in hexadecimal, are the ones after it. Now, we used arrays long before programming languages had these as a built-in feature. And what programmers did is they just put their elements in a contiguous block of memory. And all I needed to do is remember the address of the first element to be able to find all the ones after it by offsetting based on the index. Well, C++ implements the arrays in exactly the same way. Array of A0 is an address FA48. Index 5 is an address FA4D. I can also point to the first element, and I'll remember the pointer is always going to point to the first element in the array, which is FA48. So if I dereference that, I will get the number 0. And then if I add 5 to that address, which is FA4D, then that will point to the element 5. And then if I dereference it, I'll get the value 5. Let's take a look at this in a slightly different way here. I'm going to have A through J in a contiguous block of memory. These are 10 elements. And A sub 0 is slot A. And then B, C, D, all the way up to A sub 9, which will have the value J. So what's the address of the element A? Well, it's A plus 0. And then B is A plus 1, and so on, all the way to J, which is A plus 9. So A sub 0 can be reached by the square bracket operator, A sub 0, or dereference A plus 0, the address. So J can be accessed with A sub 9, or I can dereference the address A plus the offset 9. And here's the key equation here. A sub I equals dereference of A plus I. In other words, a square bracket operator is implemented simply by dereferencing the address of the first element plus the index. To see how this works, I'm going to have a 10-element array of integers. And notice I put the comments of the indices just above it. I'm also going to have 4 integer values, value 1, value 2, value 3, value 4. I'll say value 1 equals A sub 5, and when I execute this line of code, sure enough, I get 55, because that's what's in that slot of memory. So everything so far is what we expect. Now I claim that the array index operator is the same thing as saying star dereference A plus the index, which is 5. So when I run this, I expect value 1 and value 2 to be the same. Let's see if that's true here. So when I run it, value 1 and value 2 are both 55, so that's exactly the same. Now remember the commutative property of addition we learned from algebra? Then that should be A plus 5 is the same as 5 plus A. Well, I expect value 3 to be the same as value 2 because of the commutative property of addition. Nothing should change here. And sure enough, all 3 of those elements are in fact 55. Okay, now my claim is the square bracket operator is just the dereference operator plus addition. Therefore, I should be able to pull out 5 of A. Okay, that looks really wrong. But, when I run it, it turns out I'm going to get the same answer. This is completely counterintuitive until you realize that the square bracket operator is simply just the dereference operator and addition. There is nothing more and nothing less going on. So how do we implement the square bracket operator, otherwise known as the array index operator or the subscript operator? It goes by many names. Well, first of all, the square bracket operator, the full name is array T and N. Remember, T is the base type and N is the number of elements, : operator square bracket. That's the full name of the function. It's going to return a T by reference because it's both read-only and read-write. And it's going to take one parameter, which is the index. And the index is of size T, which is an unsigned integer. Now I'm going to return dereference the pointer to the first element, which is elms. I don't know why C++ standard template library decides to use that as the member variable name, but it does, plus index. Now, of course, I can use the built-in array index operator to do the same thing, and this is the equivalent implementation. Don't forget, we both have the read-only and the read-write version. This is the read-write version because I can modify as well as look at the element, but the standard template library implements a read-only version as well. Now, the at method works the same as the array index operator with one important exception. If the index is out of range, then it throws an out-of-range exception. And so the syntax can be different. Array t of n, : at, and that's going to be my full name of my method. It's going to take a size t as an index as a parameter. And it's going to return t by reference. Now, if I'm out of range, then I'm going to throw std : out of range, and then some message on to say, hey, I'm out of range. Otherwise, I'm going to return the elements. Now notice that index is a size t, which is an unsigned integer, therefore it cannot be less than 0. So you can make an argument in the first part of the if statement. The first clause of the Boolean expression in the if statement is unnecessary. Of course, the read-only and read-write version need to be provided for the add operator.